Okay, so hi everyone, my name is Sam Driver. I'm the lead developer on the portal and API side at GivEnergy. I've been working for GivEnergy since July 2021. I joined the team as a developer. The development side of GivEnergy was sort of in its infancy at that point. And since then, I've become the team lead for that side of things. I've been working with GivEnergy hardware for about 6 years, so basically since GivEnergy was founded. But yeah, I've been an official employee of GivEnergy since 2021. So my knowledge of how the data works and sort of how the hardware works at like a user experience kind of level is quite broad, just because I've been with the company for a good few years. So I think I'm the best person to answer a lot of these questions regarding like portal and how things work like that. So yeah, I'm just going to get stuck straight in. So our lovely marketing team have given me a list of questions, and I'm just going to go through them from the top. So the first question: are there any notification features being developed on the app or portal, i.e. when the battery or car is fully charged, key times to export back if on, give back, etc.? So we're not actively working on anything right now. However, we have just made quite a few infrastructure changes that will enable us to do things when certain things happen. So for example, if your home battery is fully charged, we are now sort of aware of that in terms of our infrastructure, so we can trigger some custom logic when that happens. Same could be for if your system raises an alarm, if you're exporting to the grid over a certain amount, if your solar starts or stops generating, that sort of thing. So for inverter data and inverter events, yes, absolutely, we can add in events on top of that, so we can notify you when that happens. With EV chargers, we are a little bit more limited just because of the data we get back. So we do know from the EV charger, we do know when a charge starts, we do know when a charge stops, but we don't know, unfortunately, when the car battery is full. We just don't get that data back from the car, so we're not able to do that. However, yeah, we can do things like alarms, start a charge, stop charge, charges reached a certain amount, that sort of thing. And with smart plugs as well, we could do something similar. So smart plug turns on, smart plug turns off, smart plug energy reaches a certain amount, smart plug power reaches a certain amount. Next question: are there any plans to add additional charge discharge slots on the portal for existing products? So our R&D and firmware teams have said that basically hardware that exists now that doesn't have the 10 charge discharge slots won't be able to have it. Obviously that might change in the future. We might come up with a solution, but we've been told by those teams that that's not possible with the current hardware. So basically that hardware would be any AC coupled inverters, single phase, except the all-in-one, and generation 1 and generation 2 hybrids. So they said it's hardware limitations, so there will be a no on that one. However, since we have software, we have the cloud, there's every possibility that we could make, so we've sort of conceptualized them as virtual discharge slots. So you would still use the same interface, you would change the slots via the inverter card or via the remote control page, but what that would do is, instead of sending a command to the inverter and letting the inverter manage that, we could do all that in the cloud. So the only caveat there is that the inverter does need to be online for that to happen. Obviously, the way it works now is if you set an AC charge time, that gets sent to the inverter, and then the inverter will execute that at the time that it needs to be executed. So if the inverter does go offline but is still functioning, those AC charge slots would still work as normal. So with these virtual slots, if we were to develop them, it would require that the inverter would need to be online. Okay, next question. What does each charge mode do, and which is the best to use on the day-to-day? So we've got 4 primary modes, and I'll go through them in some detail. And we've also got 2 that they're considered modes because they're in like the same part of the portal in the app, but they're more configuration, and again I'll go into them. And then once I've sort of gone through the list, we'll talk about what is best for what sort of use case. So the main mode and the way that our systems work by default is eco. So what eco mode means is that if you have a surplus of solar energy and your demand is not great enough to require all of that solar energy, i.e. if you didn't have a battery, that solar will go back out to the grid, the system will dynamically charge the battery with any excess solar. So any solar that would have gone back out to the grid will instead go into the battery. And if we flip that around and we say in the other way, if there is more demand than what the solar can provide, i.e. if you would have imported from the grid, if there is any power or energy left in the battery, then the battery would discharge to cover that demand. So it's essentially, maximise self-consumption is the easiest way we describe that. Next mode would be time charge. So what that will do is basically you set a time, you set a start time and an end time, and your battery will force charge from the grid during that window. So if you set a start time of 2 AM and an end time of 4 PM, your battery will just charge at full power from the grid between those time periods. Now, when that would be useful is if you're on a tariff that has different prices at different times. So for example, if you're on Octopus Go or Octopus Agile or just like an Economy 7 tariff where there is a window or multiple windows during the day where you get a cheaper energy price, what you would do is you would charge the battery at that cheap price, and then once the energy prices are more expensive later in the day, you will let the battery discharge, essentially giving you that cheap energy throughout the day. Next up is time discharge. So what time discharge is, it's very similar to time charge, except instead of charging from the grid, it would discharge the battery back out, but it will only discharge the battery to meet local demand. So essentially what this is, it's the discharge aspect of eco mode, but it's on a timer. So let's say, for example, you're on a tariff that's got really high import rates between 4 PM and 5 PM, and you only want your battery to discharge between 4 PM and 5 PM, the easiest way to do that would be to configure a timed discharge. And similarly, we have the timed export mode, which is basically functionally identical to timed discharge, except instead of discharging at the demanded power, it will discharge at full power. So it will discharge your battery at full power, and if that energy needs to go back out to the grid, then it will go back out to the grid. When that would be useful is if you're on, let's say you've got an export tariff, and it's a dynamic export tariff, so it changes throughout the day. And if you had a period, let's say between 5 PM and 7 PM, where the energy price for exporting is really high, i.e. you get a lot of money for exporting, you might want to force your battery to discharge back out to the grid. And it might be more financially viable to do that rather than using the energy yourself, because you might get paid more to send it back out than you would to use it locally. Now, in terms of which of those four modes are best to use day to day, eco mode is the default logic of the system. So almost all of our systems are just in eco mode. They are in eco mode when they're commissioned, they're in eco mode when they come out of the factory. That is their default logic. The systems were designed with that in mind when they were first designed, years ago. So eco mode is the general all-rounder for all systems. You will generally want to be in eco mode all the time. Now, as I said before, if you're on a tariff that gets a cheaper price at some time, then by all means use the time charge mode. It will work alongside eco mode, it will just charge at that time. So if you do get cheaper electricity between 4 AM and 7 AM, set a time charge for that time, and then you'll be able to use that energy throughout the day. Similarly with time discharge, timed export, like I said, if you have really high prices at certain times and you want to save the battery for that point of time to sort of maximise your cost savings, then that's fine. But as I say, eco mode is sort of the one that most people use. So additionally then, the two modes that aren't really modes, i.e. they don't like change the behaviour of the system in the same way that a time charge, time discharge would. You've got the battery options. So what we can set there, we can set a percentage limit on the battery. So we can say how much power we will discharge down to. So let's say if you set 20%, the battery will discharge down to 20% and then you will save that energy. It won't use it. That could be beneficial if you've got like a backup power supply and you want to save some power in the event of a power cut. If you set that 20%, we'll discharge down to 20%. It won't use it. And then if there is a power cut, that remaining 20% will be used in the event of that power cut. And likewise, you can set an upper charge limit as well. And what that'll do is that'll just prevent the battery from charging past that point during an AC charge. So let's say if you know that tomorrow it's going to be quite sunny and you're going to fill the battery quite early from solar, you might not want to do an AC charge early on, just because then when the sun is generating, you'll probably be exporting that back out to the grid. So you'd set an upper charge limit on that. Additionally, in the battery options, you've also got the battery charge power and discharge power. Most people don't change them. It's just to sort of get that fine-tuned control over the system. Let's say if you wanted the batteries to charge a little bit more slowly over a period of time, or you wanted to limit the discharge power for whatever reason, you can change those as well. And the last mode, again, not really considered a mode, but it's in the modes area, is just the reset to defaults. And what that'll do is that will that will reset all your registers to their factory settings. So if you've set any AC charges, if you've changed any settings on the inverter, when you click that button, essentially it will set everything back to the values that it would have been when it came out of the factory. Okay, next question. The reports feature that lists my energy usage is different to my actual energy bill. Is that expected? So expected, sort of. I'll go into more detail on what I mean. Basically, the energy values that we see in the reports are calculated based on information that we take from your meter and your inverter. The reason for that is because we show things like battery to home and battery to grid, we break down battery discharge into where that energy has actually gone. But we don't, internally in the property, we can't meter where the battery energy has gone. All we know is it's gone somewhere. So we use other data to calculate that and estimate based on that. And because it is an estimation, it's a calculation, it's not going to be 100% accurate because we don't know exactly what went on between those data points. So there can be a little bit of an accuracy loss there. And that's sort of the main reason for that. Another reason is that these calculations are done half hourly. So again, between those half hour windows, there's a chance that things have changed that we've missed. And additionally, one of the big factors that does affect some people is that if your inverter goes offline, we don't get data from the inverter while it's offline, so we can't perform calculations on that data. However, the meter that's installed at the property, regardless of whether the inverter is online or not, will continue to rack up the energy values. So you could take a look at your energy that we've calculated over the course of a day, and it might say 0, but that's because your system's been offline. But if you were to physically look at your meter, there would be a reading on there, and that reading would have changed from the start of the day to the end of the day. Now, it's worth mentioning that we are completely rewriting the way that the energy flows work. So there's a big project ongoing at the moment that we're looking to release as soon as possible, really. That is a complete change to the way that we do the calculations, and it is a lot more accurate. We're using the new infrastructure that I spoke about in the first point. So this new events infrastructure that we've developed, we'll be using that to generate this new energy data. And what we're going to do on the portal, so it's going to be portal only initially. We're going to release another energy flow card alongside the first. We're going to mark it as beta or something like that, and you'll be able to have both the old energy card and the new energy card side by side. They'll look the same, functionally identical, but where they get their data from is going to be slightly different. So the old energy flow card is going to continue to use the existing energy flow calculations. The reports, the smart tariff card, everywhere is going to continue to use the existing data. But we're going to release a second card that's going to point to this new source of data. And then once we're happy that this new source of data is accurate and that everyone is seeing the values they would expect, we will then start to move other services to point at this new data instead. Okay, next question is a good one. I keep seeing people mentioning Home Assistant. What is it and how do I use it? So Home Assistant is a piece of open source software that all kinds of people, mainly automation hobbyists, will use to automate anything within their home. So things from smart plugs, smart bulbs, EV chargers, and of course GivEnergy inverters, that can all be automated using software. So what you need to do to get set up, I mean, there's tons of tutorials out there. Speak to the Geek is a YouTuber who's got really good tutorial on how to get set up with GivTCP, which is the GivEnergy Home Assistant plugin. But basically what you'll need is a Raspberry Pi or some sort of device with a modern CPU. You will connect that to your home network, you'll load Home Assistant onto it, you'll configure Home Assistant, you'll load up plugins, configure it, whatever, and then basically you'll leave it running. And you can talk to the inverter locally to retrieve its data, and you can control it locally as well. So there are some plugins out there, for example, that will integrate solar power forecasting, and it will use that information to determine how to charge your battery. So based on the following day's forecast, we might be able to say charge the battery to 50% from the grid, because we know that remaining 50% is going to be covered by the solar. That's just a slice of what Home Assistant can do. I mean, it's massive. There are lots and lots and lots of plugins out there that can do all sorts of things, not just integrate with GivEnergy hardware, but interact with all kinds of smart home. Okay, next question. How can I tell if my firmware is up to date? So when the hardware is commissioned initially, the firmware will be updated. It is a requirement for the system to pass its commissioning for it to be up to date. But if you want to check, if your system's been installed for a while and you want to check if it's up to date, what you need to do is log into the web portal. Head to My Inverters in the sidebar, or head to the inverter card on the dashboard. And on the inverter card there is a software tab. Click the software tab, and then you'll see information about what software is currently loaded onto your system and what the latest version is. If any of your software versions are out of date, if you click the update firmware button, it will start a process that just runs in the background, and we will update your firmware over the air. One thing to note, if your battery needs to be updated, it will perform a state of charge calibration, and you will be notified of this. And what that means is that when the battery firmware is finished updating, we will completely drain the battery and then fully charge it again, just to reset the upper and lower limits. Similar question, how can I see how long I've got left on my warranty? So when the system is first commissioned, you will be sent a notification to accept your warranty. So as soon as the installer has finished that commission, you'll be asked to essentially sign a warranty document, and from that point on you get your system's warranty. If at any point you want to check what the warranty expiry date is, you just need to head to the inverter card. So much like checking if your firmware's out of date, head to the inverter card, head to the general tab, and on that general tab there will be a warranty expiry date section, and I'll have the exact date that your warranty expires. Next question. I'm a British Gas customer, can I still link my energy tariff on the portal? So link, not necessarily. So we do interface with Octopus Energy, so you can link your GivEnergy account and your Octopus Energy account, and Octopus will provide your smart meter data to us, and they can also control your system on their behalf. But if you're with another energy provider, what we have available on both the smart tariff card and the portal and on the app is this notion of a GivEnergy custom tariff. And what you can do with this custom tariff is you can provide all of your tariff prices at a half-hourly interval. So as long as you're not on a tariff that changes every 24 hours like Octopus Agile, you can put your tariff prices in there. And when that's all saved, the next time you load the smart tariff card, we will have mapped all of your system's energy data to the prices that you've given us, and then we'll be able to display what you've spent on a half-hourly basis. If you're on an export tariff, you can also put that information in as well. So let's say, if you're on a fixed export tariff of 5 pence per kilowatt hour, you can enter that data, and again we'll collate that with your export energy, and we'll show you how much energy you've earned from the system. So if you do set up your smart tariff as well, any reports that you generate, so if you head to the report section, the sidebar on the portal, any reports that you generate will include that smart tariff information. Next question. Are you considering AI software to optimize the GivEnergy ecosystem by linking predictive solar generation software, weather data, and ecosystem historical data? So we would absolutely love to do this sort of stuff. So these are conversations that we've had internally for ages. Obviously, AI seems to be everywhere at the moment, and you can do some really, really cool things with it. But unfortunately, we've not made a start on anything like that just yet. I think we probably need a dedicated person to work on that. But as it stands at the moment, we are there's so much that we're working on that we just don't have the capacity to do that at the moment. However, I'm sure that the Home Assistant and the automation community will probably come up with something faster than we can. So do keep an eye out on the Home Assistant community. They're already doing really clever things with solar power forecasting and battery automation, and I'm sure that within the near future that there's going to be something that integrates AI into that as well. Next question. Any update on getting third-party data shown in the portal currently pushed up via the Smart Device API call? Yeah, so for those that don't know what that is, basically there is an API endpoint that we made when the portal was in its infancy, really, that we intended to use for people to save their own smart device data. So these are like smart plugs and various other devices that monitor power or provide power that aren't a part of the GivEnergy ecosystem. So people can send us that data and we'll hold on to that data for them. There's nothing currently in development in terms of where that data is being displayed. Regular smart plug data, i.e. GivEnergy smart plug data, is available via the app, not available by the portal just yet. But as it stands at the moment, any data that you send to us via the API for smart devices, you can also retrieve from the same API. But in terms of development, there's nothing that we're working on at the moment. Next question. Where is my data being stored? How is the portal made secure? Yeah, so all of our cloud infrastructure is provided by AWS. AWS have a bunch of ISO certifications regarding security, and they're also CSA star compliant. So AWS as a cloud provider have incredible security. They have their own firewalls and they have their own attack protection, whatever, just as a baseline. They provide that to all their customers. But in addition to that, we store all of personal data, all telemetry, everything inside a London data center, so an AWS London data center. As we expand, we are going to be adding more services in more territories, depending on what AWS offers. So, for example, this energy flow stuff had to be in Ireland just due to technical limitations. So some of the data that we do generate is stored in Ireland, but as far as it stands at the moment, all personal data that we collect is stored in a data center in London. None of our databases are accessible via the internet, so you have to basically be inside our infrastructure to access our databases, and they're all completely locked down. So essentially you have to be the software that interacts with them inside our infrastructure to interact with them. And just ongoing, we are constantly improving our security. So looking at what we can do in terms of AWS, what security features we can turn on, etc. And in terms of how we secure the data between users, so we use a well-known web framework that has like authentication, authorization built in. So we leverage that. And on top of that, of course, we test our own software as well. So we ensure that only the data that is relevant to you or to your installer or whoever should access the data can actually access that data. I've got a few more questions, but I realise I'm almost out of time, so I'm going to blast through these. Is there a process for submitting feature requests or suggestions for the portal? So yes, there is a feedback section in the app and the portal, but unfortunately due to just resources, we don't have the chance to respond to a lot of the feedback. We do see them, we just don't get the chance to respond. So as it stands at the moment, the best way to get the feedback to us is just to fire an email to the support desk. They will collate these requests or bug reports or whatever gets sent to them, and they will pass that on to us via internal channels. So we have much better visibility, and obviously with the support team being in direct contact with you, they may be able to provide updates as well as to the status of those feedback requests. Is the GivEnergy software team Chinese-based or UK-based? So we're based in the UK. All of our software is designed and developed in the UK. So yeah, myself, I'm the team lead on the portal side, but we've got 3 different teams. So my team is in charge of, we take care of the portal, API, comms platform, so that's things that your EV charger and inverter talk to. We've also got the mobile app, or we call them the consumer team. And then there's also GivEngineer, which if there's any installers watching, they will have heard about GivEngineer, but I'll talk about that maybe a bit more if I've got some time. So yeah, in 2020 the dev team had no people in it. There was no dev team. So from 2020 up until now, we have grown, and there's about 25 devs, or 25 people on the dev team in the UK now. Next question: how does the software team work with the firmware team? Are they connected? So yeah, I mean, we work quite closely. So the firmware team obviously make firmware changes. They provide us the firmware, and they provide us the accompanying documentation to tell us how that firmware works. If we spot any bugs, or if the tech support team spot any bugs, we'll feed that back into the firmware team, and the firmware team will essentially iterate their process. So anything from how we control the inverter to how we talk to the dongle, how we get the data, how we store the data, what the data looks like. That is quite a close back and forth between the software team and the firmware team. How quickly is the monitoring data in the portal updated? So this really depends. Generally speaking, inverters will send 1 data packet every 5 minutes. That can be a bit faster depending on if we've put it into debug for testing purposes, or if you've got something like inverter control enabled. Inverter control does increase the frequency of those data packets, but the typical data frequency is once every 5 minutes. Energy flow data is an exception to that. So because that's calculated, we run a script every 60 minutes. So your energy flow data may be lagging behind by 60 minutes or so, but your inverter data, it sends a data point every 5 minutes. We save it as soon as it comes in, and that's available to you as soon as we save it. Next question: is the GivEnergy API an open source API? It really depends what you mean by open source. As a software developer, open source to me means that the source code is publicly available, which is not the case for our APIs. However, we do pride ourselves as a company in giving users the ability to do whatever they want with the system. So via the API, you can control your EV charger, you can control your inverter, you can get your inverter data, you can get your EV charger data, you can get your smart plug data, and you can do all of this stuff. Basically anything that you could do via the app or via the portal, you can do via the API. And the final question, which I've timed perfectly, broadly, what updates or improvements do we plan on making within the next 12 months? So energy flows, which we've already discussed. We've got smart tariff improvements, so we're going to be looking, so we're selling systems in Europe now, and we're going to be looking to expand the smart tariff functionality to users in Europe. So we're going to fetch wholesale tariff data and allow users to optimize their system based on that. We've also got changes to excuse me, the way that EV chargers work in the app. We're going to try and be simplifying that process a little bit, just to make installation and configuration a little bit easier and a bit easier to understand. And finally, we've got the GivEngineer app that's been released. That's in beta at the moment, and what that is a really, we've really refined the commissioning process. We've made the commissioning process really, really straightforward, and we've brought down the amount of time that it takes to commission a system. Additionally, there's a lot less manual entry, there's a lot less things that can go wrong, and in general, we've tried to make it as easy as possible for installers to commission systems and get things up and running. And that's it, that's all the questions I was given, and that is bang on 30 minutes. So thanks everyone for watching. I've been Sam Driver, and bye.